In this example, we are going to use the tabular method to calculate posterior probability using Bayes' theorem. So first, go ahead and set up your worksheet to look like mine does. Let me walk you through how to enter a subscript here. So if I'm dealing with company A2, you would just go ahead and enter A2 and then highlight the part that you want to make a subscript or superscript. For us, that's the 2. Then go up on home to the little font section here. Click on this box and arrow on the lower right corner. And if you click on that, you get some more options for your font. And you can go down here and select the subscript box. If you wanted a superscript, you would select superscript. And go to OK. And you could see that it has made that 2 into a subscript for us. And again, if you need to find this intersection symbol, you find that under Insert, go over to Symbol, then make sure you're in the Mathematical Operators drop-down menu, and click on Intersection and Insert, and it'll put that in there for you. So now posterior probabilities come up when we are mid-cycle and we've come across a part that's bad. We want to know the likelihood that that part is from a particular supplier. So in our table here, we are given some of the information. We are told that that 65% of our parts are from supplier A1 and that 35% are from supplier A2. Also, it's been our experience that 2% of the parts from supplier A1 are bad, and 5% of our parts from supplier A2 are bad. Now the joint probabilities are what we calculated in our last example with the probability tree. We will go ahead and do that here real quick. So the probability that a part's first from A1 and then bad equals probability that it's from A1 multiplied by the probability that it is bad from A1. And same thing then for bad parts from probability or from supplier A2. So our 0.35 multiplied by our 0.05. Now we have our 2 joint probabilities. Okay. Now when it comes to posterior probabilities, we need to know the total probability or the probability of a bad part from all suppliers. So this is going to be the sum, the probability of bad part from any of the suppliers, each of the suppliers. So equals sum of these 2 joint probabilities. Okay. If we were dealing with more suppliers, we would simply find the joint probabilities for each of them and then the total for however many we had. So now our posterior probabilities. This is saying that I find a bad part, I come across a bad part, and I want to know that I want to know which supplier it's from. What's the probability that it's from a particular supplier? So this equals the joint probability that it's from a specific supplier divided by the probability that it's a bad part. Now, as you can see, we have quite a few significant digits here. We can reduce that, go back to home, and come up to this arrow here, and we want fewer. That's good. Okay, so now our posterior probability for supplier A2, same thing, it equals the probability that it's bad from A2 divided by the probability that it is bad. Okay. Again, we would like to see fewer significant digits, so we do that. Okay, and again, if you had more than just 2 suppliers, you would repeat that process for each of the suppliers. So what does this tell us? Well, if I come across a bad part, I could say with 57% certainty that it's from supplier A2. Or I could say that supplier A2 tends to supply more bad parts than supplier A1. Supplier A2 tends to supply about 57% of them, whereas supplier A1 supplies between 42 and 43% of them. So again, this was the tabular method to calculate posterior probabilities using Bayes' theorem.